Hey everyone, today we're back to talk about wireless access points, what they do, what layer of the OSI model they fit into, and why wireless infrastructure is one of the first places that attackers look during a penetration test. Now, most people think of Wi-Fi as convenient, but from a security perspective, wireless networks extend your internal network beyond the physical walls of an organization or home. And that means that attackers don't always need to step inside a building to start interacting with internal infrastructure. Let's start with what a wireless access point actually does. Essentially, it takes the physical Ethernet connection and converts that wired network communication into wireless radio signals. It allows devices like laptops, phones, IoT devices, all to communicate with the internal network without using a wired connection. Those wireless signals are transmitted over radio frequency bands like 2.4 gigahertz and 5 gigahertz. And your device's wireless adapters listen for those signals and convert them back into data that your system can understand. From an OSI model perspective, access points primarily operate at layer 2, the data link layer. Much like a switch, an access point bridges devices onto the local network using MAC addresses, which is the physical address of the device. So here you can see we have the access point, and right now there is no devices connected to it. So right now I'm going to connect my device to the demo Wi-Fi. My device is connecting. You can see that it shows as connected to the demo Wi-Fi, and here we have my access point again. And now you can see the client device has connected to the access point. Behind the scenes, when you type your Wi-Fi password to connect, your device and the access point perform an authentication process that verifies the password and establishes encrypted communication, so the data traveling over the air can't easily be intercepted by other devices nearby or by malicious actors. So this is where things get pretty interesting from a security perspective, because unlike switches and routers, wireless infrastructure is intentionally exposed. Organizations intentionally broadcast wireless networks so legitimate users can discover and connect to them. The thing is, those same broadcasts that can be discovered by legitimate users can also be discovered by malicious actors sitting nearby. Malicious actors can use scanning tools to scan the surrounding areas. The scanning tools essentially search for beacon frames that wireless access points broadcast in order to advertise their network. That can be discovered from access points is broadcast SSIDs, signal strengths, authentication methods, and encryption types. And just in case you're new to tech, an SSID is essentially the network name that's being advertised. So when you click your Wi-Fi button on your device and you see the names of the Wi-Fi, that's essentially the SSID. The signal strength, which is how close you are to the access point. Authentication methods such as open networks or WPA2, WPA3. Encryption types, which is how the traffic is being protected. When a client device joins a network using WPA2 or WPA3, the device and the access point perform what's known as a four-way handshake. This process confirms both sides share the correct password and establishes encryption keys that protect the wireless session. Once the four-way handshake completes, the device joins the network and receives an IP address, allowing normal communication to begin. Because wireless communication travels through the air as radio signals, attackers within proximity can sometimes capture this four-way handshake as it occurs. Once captured, the attacker can perform offline password cracking. This is where the handshake data is tested against a large list of passwords until a match is found. This process happens offline. Attackers can guess thousands or even millions of passwords without interacting with the network again. Now let's talk about segmentation. This is where wireless access points connect directly back to switches and VLANs. Most modern enterprise access points can broadcast multiple SSIDs from one single device. For example, an organization might have guest Wi-Fi and staff Wi-Fi, as well as an SSID for their IoT devices. Behind the scenes, each of these SSIDs is typically mapped to a VLAN using VLAN tagging. When a wireless device connects, the access point assigns the traffic to the appropriate VLAN before forwarding it into the wired network. In theory, this keeps device groups isolated. Problem is, misconfigured network segmentation is pretty common. Well, a guest Wi-Fi might have access to internal resources that it shouldn't have. In other cases, management interfaces for network devices may be reachable from the wrong VLAN, and sometimes wireless traffic is accidentally bridged to internal trusted networks. And when this happens, an attacker who connects to the wireless network may gain access far deeper into the environment than intended. Once an attacker successfully connects to any internal wireless segment, the situation changes completely. From this network's perspective, this device is now just another internal host. So at this point, the attacker is no longer outside of the network perimeter, and they can begin to do internal discovery by identifying things like nearby devices, observing broadcast traffic, and look for high-value targets like file servers, domain controllers, or management systems. Another major wireless risk involves rogue infrastructure. For this example, I created a rogue access point called staff network as opposed to staff. For the example, consider this a malicious access point that will impersonate legitimate wireless networks to trick this user into connecting. Instead of attacking systems directly, the attacker exploits user trust to capture credentials or redirect traffic. Attackers can broadcast network names that look almost identical to legitimate ones. If the attacker's signal is stronger, devices are likely to connect to that fake network instead, and in some cases, users are going to be presented with a fake login page where the attacker is going to capture their credentials. This is why it's important for security professionals to look at wireless infrastructure differently. Access points don't just provide convenient connectivity, they extend the organization's attack surface beyond the physical walls of the network. Because unlike wired networks, wireless networks can be reached from places like parking lots, neighborhood buildings, or even public areas. Thank you everybody for watching. Don't forget to like and follow along so you don't miss the next video, which will be firewalls.